Oh. You must be 5 feet to ride this ride. So, can I ride this ride? Let's talk about this. This is going to be all about inequalities, okay? So for the past few lessons, we've been spending a lot of time and a lot of different ways of thinking about equations, finding the values of unknowns in equations, and even in bringing in two unknowns for a special kind of equation. Let's talk about what it means to be an inequality, okay? If you're an equation, that means this side and this side of the relationship are in balance. That means there's an equal here, okay? There's equality on both sides. But in the case of an inequality, it's actually not the case. Actually, we're talking about relationships where one side is showing inequality to another side, all right? Let's start with this sign right here. Does this sign mean that only people who are 5 feet tall can ride on this ride? That would be kind of weird. That wouldn't be a very popular ride. If you walked up here and you said, oh, I'm not 5 feet, and you walked away, even though I'm taller than 5 feet, then this would be kind of a not very popular ride. Now what this is saying is that in order to be safe, people should be at least 5 feet, right? That means 5 feet or taller. So if you're under 5 feet, sorry, can't let you ride. So this isn't actually saying that I have to be exactly 5 feet. This isn't an equation. This is an inequality. This is saying that I must be greater than or equal to 5 feet, right? I put the equals right there, and if you look over here, I have my little cheat sheet here of what I'm allowed to select. I put this little sign, this little line underneath the greater than symbol to show that I can also be exactly 5 feet, okay? This isn't just for people who are greater or taller than 5 feet. You can also be 5 feet. And over here, since it could apply to anybody in this amusement park, I'm going to use X as a value to show height. Okay? X can be any height. It can be me. I'm 6 feet tall, so I'm a full foot taller than this. I can go on this ride. Do I satisfy this? If I put my height in place of X, is this a true statement? Yeah, because 6 is greater than, or equal to, but in this case, greater than 5. If my little son walked up, who's 6 years old, he's only about this tall. I'm gonna say he's about 3 feet tall. If I put in his height right here, would that be true? 3 is not greater than or equal to 5, right? So he wouldn't be allowed to go on this ride. Anybody who's 5 or higher can ride on this ride, okay? So that's basic, a very basic introduction to what an equality is all about, and inequality is all about. Let me erase this mean sign right here. It's not really mean, it's just trying to keep you safe. And let's look at another way to show what's going on here. We are gonna pick our favorite, one of our favorite models. We used it for integers, we're gonna use it for these, and that is the number line. So I'm gonna draw a nice big number line. I'll put 0 like right here in the middle. And the reason I'm gonna do that is because I'm gonna show you another inequality on this same number line to kind of show you a difference in what's happening. So I'll do the positive side. 8, 9, 10, 11, that's good enough. 1, 2, 3, 4. If you look right underneath this video, you'll see that I've attached some number lines there for you. So if you don't want to draw these every single time in your journal, what you can do is you can print that sheet of number lines that I gave you and actually cut them out and just paste them in your journal. So every time I draw a number line, all you got to do is cut and paste. Lucky you. And then we'll do, whoops, that's a little too close. Then we'll do the negative. This one goes out to -10, okay. So on my amusement park ride, this is my inequality. Anybody who wants to ride this, their height must be greater than or equal to 5. Now what does that look like here, okay? Now first of all, notice that 5 is included. It can be equal to 5. So I'm gonna mark 5 on my number line with a nice solid dot. A solid dot on a number line basically means that that number is included. If I don't want to include the number that I'm actually marking, then I'll leave that dot open. So here's another little key I'm going to put up above just so I can remind myself of what my mark should look like. In this case, x can be 5, so I'm going to go ahead and include it in my model here. All right, so now what? Well, I also want to show what other heights people can be. Because I already decided you don't have to be exactly 5. You don't have to be exactly 5 feet to go on this ride. You can be bigger than that. You can be taller, right? So there's a couple ways people do this. If they want to show that 5 is the starting point and we can keep going bigger and bigger, sometimes they'll darken the original number line with a nice big arrow right here, just to show that this is that inequality on here. I don't like doing that just because it gets a little messy. So basically what I do, and I generally incorporate color here, just so I can see it really good. I make a nice vertical line coming out of the mark, and then I make a new arrow. See how that works? Instead of darkening the original number line, I make a brand new arrow. Or I make a new line. So this red line right there shows this. And sometimes you'll even see people write the original inequality on top of it just so they don't lose track. Okay? X can be 5 or anything bigger. X is greater than or equal to 5. So I've marked the 5 so that it's included. Nice dark mark there. And then I drew a line showing that any number bigger than 5, any height bigger than 5 is allowed to go on this ride. Now in a real life scenario, this kind of doesn't make a lot of sense because I don't know a lot of 9-foot people who ride roller coasters, and I don't even think I know any 11-foot people. And this line mathematically keeps going all the way to infinity. Okay, so it gets bigger and bigger and bigger. But mathematically, that's what this statement says. Now, a little bit later, we will talk a little bit on how to limit that line so it doesn't get ridiculously big. But for now, let's go ahead and just make sure we understand that this mathematical statement here, this inequality, is modeled like this. Now, what if I wanted to show, well, my niece, who's 4, can't go on this ride, right? She's not 5 feet or higher. So we walk her over to the kiddie part, and there's another sign next to the cute little train or whatever they ride on that says you must be under 4 feet to ride, okay? It doesn't include 4 feet this time. I don't know why, but this time it says you have to be under 4 feet. So how does that look as an inequality? All right, we can go ahead and use X again because why not? X is under 4 feet. So now we're looking for one of these that means under or less than. And it's this one, right? Am I going to use less than or equal to? No, because in this scenario, like I stated, the sign says you have to be under 4 feet. So 4 feet is not included this time. This time you have to be less than. So anybody who wants to walk up and ride this ride has to be less than 4 feet tall. Okay? So how does that look up here? Well, let's find the 4 feet right here. And since you can't be 4 feet, this time 4 is not included. So I'm just going to circle 4 with an open marker. Make sense? Okay, now I need to show all the numbers that are smaller than 4. Okay? I want to go ahead and do my vertical line right there above the marker, and I'm going to draw a brand new line that shows all the numbers less than 4. That's a lot. And again, this isn't real life, because imagine you have somebody who's less than 4 feet, maybe they're 3 feet. I guess that's reasonable. 2 feet? Now we have like little babies. I don't know too many babies that are gonna ride on a kiddie ride by themselves. 1 feet, I don't even think I know anybody who's 1 foot tall. And then we get into the really weird and ridiculous ideas. You can't have 0 height, obviously, because then you're not even there. And then you can't have negative height, because then you're basically going inside out, which is like weird sci-fi stuff, okay? So again, this isn't really gonna work in real life, but mathematically, this mathematical statement, this inequality, looks like this on a number line. And again, a little bit later, we'll talk about how to limit this line so that it doesn't go into ridiculous numbers, all right? For instance, if I wanted to say in a real life scenario, to go on this little kid's ride, you have to be between 4 and 3 feet, okay? And that would only make the line go here. And I'll show you how that looks mathematically in a later video. But for now, I just wanted you to be able to look at these and know how to put them on a number line, okay? Here's what's gonna happen. Actually, I didn't make an exercise review for this because I want you to practice with the number line. That's the big deal. I want you to be able to look at an inequality like this and put it on a number line. I want you to be able to look at a number line and see if you can make an inequality out of it and play around with that a little bit. So right underneath this video is a link to 4 different exercises that have answer sheets underneath them, okay? So practice those right there, and then we're gonna come back in the next lesson and talk about solving inequalities, just like we did with solving equations, but this time, we're not looking for just one number, okay? So meet me in the next lesson. Good luck on those exercises, and we'll see you soon.